Okay, this is the review for summative 5. Guys, how do we deal with the domain when there's a radical? What can we not put into a radical? Negative numbers, yes. So whatever's, whoa, what's happening? Whenever we have a, okay, we'll change colors too. What's underneath the radical has to be greater than or equal to 0. It can't be negative. So if we just subtract 1, we get that x has to be greater than or equal to negative 1. So in interval notation, what would that look like? How do you say negative 1 and up? Everybody okay? Anybody awake? I know it's Monday. All right. Then it says we're supposed to add f and h. Yeah, that's a mess, isn't it? Negative square root of x plus 1 minus 3 plus 2x squared plus 4. Not much we can simplify there. What's the only thing we can combine? Yep, negative 1 and positive 4 back here are like terms. So in any order, you would... Oh, this was a 3. Yes, thank you. I copied that wrong. That was a minus 3 back there to begin with. Thank you. So in any order, I would not be picky about that. You have a square root of x plus 1 with an opposite in the front. A negative 3 plus 4 would be a positive 1. And then there's a 2x squared. So that's messy. I don't know that it's quite that messy on the quiz, but it's fine. That's not complicated, right? Only add like terms. All right, g times h. You do need to multiply that out. So again, you can multiply in any order, but you're going to have to FOIL. You know what? Does everybody have that one down? Because I think I have this on another slide with more room. Everybody good? I'm going to do this number 3 here. It says g times h. Okay, so if I do negative 4x times 2x squared, that is a negative 8, but an x times an x squared is an x cubed. Everybody with me here? If I distribute that negative 4x to the 4 back here, I'd get a negative 16x. The innermost two terms here will be a 5 times a 2x. Those are both positive, so I get a 10x squared. That was a 2x squared. I might have said that wrong. 5 times 4 on the back is plus 20. It's not wrong in that order. I would not worry about it, but if it was a delta math question, I know they want you to put them in standard form, which means decreasing order of exponent. Okay, you don't want to factor anything out. You don't want to do anything. And there aren't any like terms that combine. Any questions? All right, and then h minus g, what's everybody going to forget on that one? Yes, we got to distribute. We're subtracting all of g. So we're not foiling this together. So those parentheses are only there to remind us to distribute this. It would become a plus 4x and a minus 5. 2x squared plus 4x minus 1 when I combine these like terms. Did anybody else have that? I hope someone's telling me if I make a mistake. Okay, so that's adding, subtracting, multiplying. That brings us to dividing. And composition. Remember this, I don't have the functions on here. That's not helpful. Okay, so this one says put -6 into what, guys? Again, I highly recommend that you don't worry about finding the equation for g of h. You just put -6 into h. So h of -6 would be 2 times -6 squared plus 4. 76 maybe? Anybody type in that for me? 36 times 2 is 72 plus 4 is 76. Okay. And then that answer is that 76 that we found goes into G. So G of 76 would be -4 times 76 plus 5. I don't know what that is. 4, 304, -299. Okay, how you feeling about that? Do you need to practice another one? You okay? Just do it backwards. Put -6 into the H and then that answer into the G. All right, and then we have the divide one that I thought was coming up here. It says if f of x is this and g of x is this, find g of f of x and give any domain restriction. Okay, this means put f into g. Here's g, right? And this f is supposed to go in there. Okay, what happens when I combine like terms in that denominator? I get 1 over 2x squared minus x minus 3. Does that seem right, guys? Okay. Domain restrictions for this, remember, are whatever make the denominator equal to 0. So 2x squared minus x minus 3 cannot equal 0. It has an x squared, so you do have to factor. The only way to get a 2x squared is a 2x and a 1x. The only way to get a 3 at the back is a 3 and a 1. I think we want the 3 here and the 1 here, because I think we want, let's see, we need a negative and a positive. I'm going to go with a negative here and a positive here. So this arch gives us a -3x, and a 2x times a positive 1 is a 2x. So when we add those for the middle term, we get a -1x. Remember, we're not factoring this. We're factoring this guy up here. So if I set each of those equal to 0, I would get 2x equals 3 or x equals 3 halves. And x plus 1 equals 0 would make x equals -1. So the domain restrictions are x cannot equal -1 or +3 halves. And it doesn't say you have to be in interval notation, so it's okay to just write it like that. All real numbers except, and if you just forgot the all real numbers, I wouldn't even care. We good? Next lesson starts with a bunch of factoring, by the way, so don't think that's going away. All right. Then we get to transformations. Okay. For transformations, this one says write a cubic function. Okay. A cubic function is x cubed or ax minus h cubed plus k. And we're supposed to vertically compress it by 1/2. Is vertically inside or outside, guys? Outside, so we'd have a 1/2 on the outside. Shift it down 5, where is that? It's also a vertical shift, so it's on the outside. So down 5 on the back. Both of those do exactly what they seem because they're vertical. No doing the opposite. Now reflect over the x-axis means to do what? It means flip it up and down. But does anybody know the trick to this one now? If I just put a negative out here, yeah, it would do it before the shift down 5. Yeah, I will not require one on the thing that has extra parentheses like that. And these interior parentheses around the cubed are not necessary. Did I change this question from what your paper says? This next one? No, is that what it says? Okay. I may have changed it from the original version. I can't remember. All right. Horizontal stretch by 3. Okay. That is inside, and so it's the opposite of what it seems. How do you stretch by 3? Yeah, you put a 1/3 in there. Reflect across the y-axis. That's left to right, so that is also inside of there. And the fact that it doesn't matter which order on those two things. And then move the whole thing up 7 would be a +7 on the back. And I'm pretty sure I didn't ask you one with a horizontal stretch or shrink either on the quiz. So this whole question is kind of trickier than what's on the quiz. All right. But I gave you a lot of practice here. Let's see. What about this one? This I think I could ask you. It's got a lot of things going on, but can anybody tell me what this would look like? Yes, Jada? Okay, so if I saw this, I would go left 3, shrink vertically by 1/2 and reflect over the x-axis. But I think because of those things, left 3, reflect upside down, and then vertically shrink, the order wouldn't matter, okay? The up 5, that has to come last because when you reflect vertically and shift. So we're all good. Yes. You have another problem after this? Did I skip something? Oh, another row on this one? Oh. Yeah, what does it say? Like this one? Oh, sorry. Do you have this one? Did I just do it out of order? Okay, sorry. Gotcha. All right, so let's talk about these because you do have to do a writing question like this. All right, so we start inside here. What does that do, guys? Okay, so that is a horizontal shift, which I don't care if you put, but it is left 5. I would, yeah. I would prefer you said shift left 5, but I really don't care. Yep, left 5. And then what's the next thing though? Be careful. If I told you to put a 2 in here, you would add 5, then take the absolute value, then before you subtracted the 1, you'd have to multiply by the 3, right? What is that 3 doing? Yep, vertical stretch by a factor of 3. So that would change y values, okay? And then the last thing is a vertical shift down 1, as it's on the back. Everybody okay? And that is one you could graph and look and make sure that that made sense. All right, anybody trying this one? Again, start inside here. That is a horizontal shift which way? Right 2. Then what's the negative do on the whole thing? Reflect over x. It's the up and down one. Or they would say a reflection in the x-axis. That just doesn't make sense to me, but okay. And then the last one is a vertical shift up 7. Yes, you can say over, yes.
The reflection over the x-axis first. Can I do that on the quiz, or does it
Let's see. As long as it became before the vertical shift, yes, you're good.
Okay. Because I put the reflection of the x-axis, then right 2, then up 7.
Yes. That wouldn't matter. All right. I don't know that I put one on the quiz where you have to actually, but I think you have to do matching of these. Anybody have a preference which one we do first? So just start with this one. 2f of x I'll do on this graph right here. What is that changing, guys? Yes, so the y values are multiplying by 2. Okay? So this had a y value of 0, and this one had a y value of 0, so those aren't changing. But these 2 points, this was 0, 3, it's now 0, 6. And this dot was 2, 3, it's now 2, 6. Any questions on that one? Again, you don't have to sketch it. You would have to match that 2f of x to that picture on the quiz. Yes?
So do we have to sketch any of these on the quiz?
I don't think so. I think it's just matching this time around. If we have to retake it, it might not be matching. Matching is easier for you and for me to grade, but it's also very hard to make those questions, so we'll see. How about the 1/2 while we're at it? Can I do that one on this graph, and then I'll go to another slide for the other 2, so I have room? 1/2 f of x would do exactly the same thing, but instead of multiplying by 2, it would take half. So the y values here were 0, right? We had -3, 0, and +3, 0, so those aren't changing. But these were up at 3, so now they're going to be up at 1.5. But the x values aren't changing, so it's 0, 1.5, and 2, 1.5. So that is a vertical compression or shrink by 1/2. And this one was a vertical stretch, just so you're practicing that vocabulary. Any questions? Okay, the other 2. It's okay if I go to another slide to put the other 2? I want to make them nice and big. So let's do this one here. Two things. Uh-oh, what two things happen, guys? Inside here, that is shift left 3. And then opposite in the front would be reflect over x-axis. I don't know if I can do both of those at once. If I shift the whole thing left 3, it would look like that. And then I'm supposed to flip it upside down. So this would be here and here. And instead of going up 3, I'm going down 3. All right, so this one was at -3, 0. It moved to -6, 0, because it shifted left 3. This was at +3, 0. It moved to 0, 0. This one was at 0, 3. So it shifted left 3 to -3, 3, and then the reflection put it down at -3, -3. And this one was at 2, 1. When I shifted it left 2, it was at -1, 1. And then when I reflected, it was at, I'm sorry, it was, that was 3, 1, right? Okay, let's try again. 3, 2. Holy moly. It was at 3, 2. Oh, someone just help me here. Was it originally at 2, 3? No? Yes? So when we shifted it left 3, it was at -1, 3. And when we reflected, it was at -1, -3. Okay, I think I finally got the sentence right. Oh, what's the last one? Horizontal compression by 1/3. And it is changing x values. Okay, so where this one was over to -3, 1/3 of that is -1. The whole thing is only going to go to there. This one was at 0, 3. When you multiply 0 by 1/3, it doesn't change, so it's still up at 0, 3. This one was at 2, 3. You're multiplying the 2 actually by the 1/3. So it's at 2/3, skinny. And then the last one to the right here was at 3, 0. If you took 1/3 of that, it would be at 1, 0. Okay, I can't even make it as skinny as they want. All right, but if I graph that, could you recognize that as a horizontal compression, that it's been pinched in and the x-axis, the x values changed? All right, so matching, think would be okay? Write down, if you need to, write the words next to each one, okay? So then I at least know you understood that much if you can't figure out the right graph. Okay, this is probably the thing I'm most worried about because I feel like we didn't practice this enough. Anybody know the parent function here? Good job. So if we start doing transformations, it's going to look like this, because I'm not going to give you horizontal ones. So normally it would go through 0, 0, 1, 1, and then over to 4, it would be up to 2. It would look like this. What happened? Can you tell me where this dot that was at 0, 0 wound up? 6? Is it at -6, guys? So left 6, up 1, and at some point it reflected over the x, right? We got to be careful with the order on those, but I think we'll be fine. Anybody want to put those numbers in there somewhere? How do you do left 6? X plus 6. How do you do up 1? Okay. And it's going to have a negative because it's upside down, but I think we actually, we'll take care of itself in a minute here. This is where we had to find the A, and it will say show work for the stretch. Okay, that's the A. So we need to put an ordered pair in. Can I pick this one? -2, what is that? 1, 2, 3, 4, 5. Anybody getting that that's -2, -5? Do I have the ordered pair right? Okay, so I'm going to put in a y of -5 when A is -2. All right, and remember this is multiplied together. So I can subtract 1 over here. -2 plus 6 is 4. Guys, what's the square root of 4? So A is, when you divide both sides by 2, you get -3. Did that take care of? Huh? -2 plus 6 is 4. The square root of 4 became 2. Yep. I should have written that in there. All right. So final answer was y equals -3 square roots of x plus 6 plus 1. So this would say left 6, vertical stretch, reflection, and up 1. It doesn't matter. It does match. Can you type this in your calculator and it should look like exactly this? Okay. So this is a check on your calculator. Question. Everybody know what I'm talking about? Type it in. Make sure it's going through those ordered pairs. All right. I think the one on the quiz might be a cubic, which would be like this. Just a hint, okay? You would care about this point. That would give you your H and K, and then you would put in some other ordered pair maybe to find A. We can do more examples in a minute, but let's get to the piecewise. Oh my goodness. Okay, piecewise. This first one is just simply evaluate. So if I put in a -5, which rule does it go in? Everybody good that it's the first one? So f of -5 is -2 times -5 plus 4 squared. Okay, you can type that in your calculator if you need to. I'm thinking it should be -2. Because -5 plus 4 is -1, but when you square it, it becomes +1 times that -2 out front. Anybody getting that? Okay. Second rule, put in a -2. Does that go in the same rule? Nope, that goes in this rule because it had the or equal to right there. And f of -2 just comes out what? That rule doesn't have an x, it just says stay at 3. All right, and then f of 4. Which rule does that one go into? That is greater than 3, so f of 4 is -3, absolute value of 4 minus 5 with a plus 9 on the back. Okay, 4 minus 5 is -1. What do you do to get it out of the absolute value? Students get this question wrong all the time. Absolute value of -1 is 1. Can it still become negative when you multiply it? Yes, so this is -3 times 1 plus 9, which is 6. Okay, on the calculator, do you remember where that button is? If I wanted to type that in, was -3 math, arrow to the right, absolute value of, I don't remember then what was the rest, guys. 4 minus 5 plus 9. And we got 6, yes? Okay. So make sure you know where it is on the calculator. All right. We are to accurately graph this mess. All right. What are the 3 shapes we're looking at? Well, you know what? Let's put it in our calculator because I think that's the way some of you are going to want to go. Go to y equals and type all 3 of those in. -2 parenthesis x plus 4. Do you want to do them one at a time, guys? Quantity squared. I think it's less confusing on the table, maybe, if you don't put them in all at once. Is that true? If you put them all in at once, the table has a whole bunch of stuff on it. Okay, so if I just graph that with a zoom 6, I want the values where? All where x is less than -2, yes? Do I include -2? Yes, is the answer to that. You have to go right up to -2. But what are you going to put at -2? An open circle, but you have to graph it. So if you wanted to trace to -2 just to see where that was on the graph, it's all the way down here, okay? But otherwise, go to the table, and we want values less than -2. So there's a bunch of them, -2, -8. Is where our open circle goes. And then I'm supposed to be going to the left, so it says -3, -2. And it says -4, 0. And it says -5, -2. And really, that would be enough to know that it's going back down this way. So we're good. Because it says all values less than -2. Everybody okay? Can I not use a calculator for the next piece? If I do this one in blue, what does that look like? It says stay at 3, right? From where to where? -2 to +3. Any solid, open, what's happening? -2 is solid, but +3 is an open circle. Okay. Everybody good? All right, what shape is this next one? It's a V that opens down, okay? Do you remember how to put that in? We just kind of reviewed that. If we went back here and we got rid of this parabola, and somewhere we put in -3, math, arrow to the right to get the absolute value, x minus 5. If you had an older calculator, it would literally say ABS, and then you would need to close the parenthesis to show that you're now out of the absolute value and put the +9 on the back. If you graph it, this is what it looks like. We want values starting at 3, so if you wanted to trace 3, it's going to start here, so we want values going to the right of that. But again, you can just use the values from the table, but I have to scroll down until I have values greater than 3. So here's my list. I have to start at 3, despite the fact that it says greater than, because I put an open circle there, which is at 3, 3. Huh. Now that I have filled that in, it's filled in, right, guys? Oh, it's supposed to be open. Neither one of those were included. Is that what yours says? Undo. Yeah, it was supposed to be open because neither one includes the 3. My bad. All right, then go to 4, 6, 5, 9, and back to 6, 6, 7, 3. That's enough. It's a V this time, not a U, so make it pointy. This one was supposed to be rounded. Okay, I don't know that it's that I doubt there's both an absolute value and a parabola on yours. Probably has either an absolute value or a parabola, and then a line. Okay, where is this one discontinuous at? Guys, the only places it can be discontinuous is the places it changed rules. Was it discontinuous at -2? When it jumped from this rule to the other? Yes. Was it discontinuous at 3? Yeah, this one was because it had a hole there. If this had said or equal to 3 so that you had filled that in, then the only discontinuity would be at -2. The discontinuous question on the quiz is a multiple choice question. I give you a bunch of values, but remember the only place it really can be discontinuous is at when it changed rules. All right, gonna write the piecewise real fast. This one's an easy one. What are the restrictions? Do you remember how this goes? F of x. Okay. This one is supposed to have an arrow, so what are the x values for that one? Here, I'll do it in red. What are the x values for this guy? Everything less than -1? Again, we're using our x values up here, guys. It's -1 and going to the left. All right, if we wanted to do the same for the other one, this one starts at -1 and goes to an x value of 3. Okay, -1 and +3. Do you remember how that works? You always use less thans when you have a sandwich and it has to go least to greatest. Okay, least to greatest. If it said A is less than X is less than B. And the first one, the -1, had a closed circle there. All right, what was the red line's equation? The Y value stayed at -4. I cannot stress enough, what everybody gets wrong is the slope because they forget there can be negative and positive slopes. Is this slope, by looking at it, left to right, it's going down. So this should have a negative slope. What is it going down by? Just 1 and over 1, right? So a -1, and then it crossed the x at -3. And you could just have a -x minus 3, but this is mx plus b form where this is your slope and this is your y-intercept. What if it doesn't cross the y? Can you figure out still where it would cross the y? And that's the number you use. Okay. Now, oh, we still haven't done inverses. All right, I'm going to record the rest of this if we don't get through it, but what does it mean for a function to be 1-to-1? Inverse will also be a function. And it means it passes both horizontal and vertical line test. So sketch a function that is 1-to-1. There you go. Sketch a function that's not 1-to-1. Is everybody good? This would pass a horizontal and vertical line test. This will not. Can I move on? Because this is the one I'm worried about. Okay. We have to switch this. It is currently a y. We make it an x. Then this is 3y minus 2 over 4y plus 1. What are the rules? Cross multiply. Who would like to tell me which way to go for that one? You want to go this way first? So 3y minus 2 equals... Okay, you want me to do it all at once? 4xy plus 1x. Everybody okay? You remember to distribute that? Okay. We need to move everything with a y one side. And everything without a y to the other side. So I get 3y minus 4xy equals over here 1x plus 2, or just an x plus 2. We're almost done. We take out a y, that leaves 3 minus 4x. And then the last step is to divide by that. So we end up with y, or this crazy notation, I don't care which you use, equals x plus 2 over 3 minus 4x. Now, you could have gotten something totally that looked different, like this. Okay, there are different ways to write that. What did I leave off? How do you graph an inverse? Yeah, so if this is 4, 0, it becomes 0, 4. If this dot was 3, 1, it becomes 1, 3. If this dot way up here was 1, 9, it becomes 9, 1. So it would look like that. Yeah, just turn it back in. You can even turn them in tomorrow if you want. You can turn them in today, I don't care. I'll take it. Yep. All right, the one we skipped, if this was a y, when you switched, you'd have, then you'd add 4 over here. Divide by 5. Square both sides. And then subtract 2. And you could leave it in that crazy form. All right. That's the recording for the review. Sorry we ran out of time, guys.